is relative velocity? Just like relative displacement, relative velocity is velocity of one object with respect to another object. For example, let us consider a train as seen by a person on the platform. The person is sitting in the platform, sitting on a chair in a platform, say, and he will notice that the train is moving. But if I ask a passenger inside the train, he will tell, with respect to me, the train is stationary. So, the perceptions are different. This is what is called as relative velocity. Now, let us get an expression for relative velocity. Let us see how to do this one. To do this one, let us assume that this is the origin and A is located here at t is equal to 0. So, we represent it by this symbol, and B is located here at t is equal to 0. These are the initial positions. Now, assume that A is travelling along this direction at a speed VA. This VA is as reported by the person at the origin, and B is moving at a speed VB as reported by the other person, that is the origin. So, now let us get their respective positions later at some after some interval of time. So, after a time t, particle A is located at xa, which is equal to its initial position plus the distance travelled by A. Suppose the time interval is t. This is the extra distance travelled. I will call it as delta x. This must be equal to its velocity into time. So, its final position must be initial position plus the displacement it undergoes. Likewise, if B comes over here, say, then the displacement of B is equal to VB into t. That is the displacement of B. So, final position of B is its initial position plus the distance it travels. Now, let us subtract equation 1 minus equation 2, or say equation 2 minus equation 1. What do we have? xB minus xa is equal to xB of 0 minus xa of 0 plus VB minus VA into t. That is right. So, if you look at this equation carefully, this is nothing but displacement of B with respect to A after time t. This is displacement of B with respect to A, or position of B with respect to A at t is equal to 0, plus we get this VB minus VA into t. Many a times it is convenient if we choose them to be at the origin. So, we write it like this: xBA at t is equal to xBA at 0 plus VB at time t. This equation is very similar to equation number 1 or 2, right? One was something like this: xa is equal to xa at 0 plus something like VA into t. But this time you notice that we have VBA. This term VBA, which is basically VB minus VA, is called relative velocity of B with respect to A. So, relative velocity of B with respect to A is represented by VBA, which is equal to VB minus VA. This is also written like this: this is velocity of B as seen by A. So, both of them mean the same thing here. So, the question is, what is VAB then? VAB is VA minus VB, but what is this? This is nothing but velocity of A as seen by B, or relative velocity of A with respect to B. You may notice an interesting thing. VAB is VA minus VB. VB is VB minus VA. So, if you look at these two, they are negative of each other, or VAB is equal to minus VBA. That means relative velocity of one object with respect to another are equal in magnitude, but they carry opposite signs.